So the fourth data type that we're going to be talking about are enumerations. We call them Enum for short. So we're going to see that an enumeration type is actually a set of named integral constants. And the index, or the value of the very first one, is going to be 0 unless it is specifically specified or initialized to something. And all subsequent ones will just be the previous enumerator plus 1. So in general, it would go the value of 0, 1, 2, 3, unless I set one of those enumerators to something else. And we'll see what that looks like. Numerator and enums, or enumeration types, are really good if I want to force or specify a range of values that the variable can take on. So here's an example of what this might look like. So I'm going to use the keyword enum, I'm going to give it a name, and then inside of the curly braces, I'm going to put a comma-separated list of values. And then I need that semicolon. I want you to notice that there is no equal sign. I'm not saying variable name equals. I'm just saying var name with the curly braces. All right, so this is what it might look like. So I'm going to create an enum called team, and then I'm going to put comma-separated values in there. These are obviously string values, but I'm not declaring a data type. I am going to create another enum called class. This is obviously integer data types, but these are actually integral constants. And so this is what it looks like if I wanted to give each one of those an index value or a value. So for right now, Sam would have an index or a value of 0, Juan would be 1, Sarah would be 2, and so on and so forth. And the same as 1030. If I were to access 1030, its value or its index would be 0. 1400, its value would be 1 as we move through the values. But this is what it looks like if I were to change those values. So here we have A, B, C, D, and E, 5 integral constants. The value in A is going to be 0 because that's where it defaults to if you don't set it to something else. B is going to be 1. We go 0 and 1 because it adds 1 to the previous integral. I am actually going to initialize C to the value of 10. So if I were to print out C, it is now going to equal 10. If I move on to D, the rules state that the next enumerator is going to be the previous enumerator plus 1. So we're going to go 10 plus 1, which is 11. And then E, I am setting it to B plus C, which is going to be 1 plus 10, which is also going to be 11. So enumerators, what is the point of an enumerator? Well, here's an example of a class that we were saying. There's only 5 options for a variable of the enum class. So if I were to create a class object called my class, I could set it to 1410. If I were to create a class object called your class, I could set it to 2420. But if I were to create another class object and attempt to set it to 1010, that would be an invalid value because it is not one in the list. Now, if I were to print out my class, it would have a value of, what do you think? What do you think the numeric value that 1410 would contain? If you said 2, you were absolutely right because 1030 contains a 0, 1400 contains a 1, therefore 1410 would contain a 2. This is a great way for me to, instead of just having some random numbers, I can actually give meaning and value to each one of the things in my list. So 2420, 0, 1, 2, 3, that actually contains a 3. So here's an example of the shortcut way that we can declare objects or variables of an enum class. I'm going to create one called all students, and I'm going to have all 5 of the students. And if you'll notice at the end, I have given it a variable called team1 with the semicolon at the end. So let's talk about the similarities and the differences between these 4 data types that we have been talking about that allow multiple values inside of a variable name. So all 4 of them store data of some form. They can be all be declared and instantiated to hold very specific data. And then all of them provide some way for us to be able to access, to set and access and manipulate the data that's being stored in there. So pretty generic sort of similarities, but now let's look at the differences between the 4. All right, so I don't want to read this whole list to you, but we're going to be seeing is that arrays are all fixed size, homogeneous collections that are providing constant time access. Vectors, on the other hand, are dynamic sized, which means they can add and remove elements. They're also homogeneous collections, which means all the data types are the same. They allow the resizing. There is flexibility, but there is a cost of potential allocation overhead. We're going to see that structs are actually an aggregation of heterogeneous data. It supports grouping of related variables and methods as well. We haven't seen that in arrays and vectors. And then finally, enumerations or enums are named integral constants that represent a fixed set of possible values. So there is a list of possible values that it can take on, which is a way to enhance code readability and type safety. So how do we choose which one of these 4 group type data types do we want to use? Well, it just depends on the specific requirements that we're looking for. The requirements of the task. Do we need a fixed versus dynamic sizing? Do we need homogeneous versus heterogeneous data? And obviously the importance of having named constants as a part of the group. So how about if we try it out? We're going to create some enums, see what we can do.